Students, in the last segment, we came to know about binomial expansion theorem or binomial theorem. This is how it looks like. In this segment, we are going to answer some basic questions on binomial theorem and we'll do some maths. So, concentrate. On the basis of binomial theorem, the first question is how many terms are there in this expansion? So, you are asked that how many such terms are there? Can you count that? Yes, you should. As we know that the basic or general term of a binomial expansion is NCR a to the power n minus r into b to the power r, where r value always changes, right? How? Here r value was 0, then r value was 1, then 2, then 3, right? So we are supposed to count the total number of terms in this expansion. If I put a partition here and look to the right side of the partition, we get that this is 1, this is 2, this is 3, this is 4, and it will end at n. So how many terms will be there? With changing r values, starting from 1 to n, there will be total n number of terms to the right of this partition, and we are also left with another term to the left of this partition. So there are total n plus 1 terms in the expansion of a plus b whole to the power n, right? So we know that a plus b whole square equals to a square plus 2ab plus b square. How many terms are there? 1, 2, 3. And we saw that here n value was 2. So the total number of elements was 3. So if you are asked that in the expansion of a plus b whole to the power 100, how many terms will be there? You'll say 100 plus 1 equals to 101. Okay, so the next question is, what is the serial or order of the term NCR into a to the power n minus r into b to the power r in this expansion? It means NCR a to the power n minus r to b to the power r. ঠিক আছে, এটা কততম পদ এখানে? Okay, so you are asked the serial or order of this term. How will you determine that? It's also easy. As you can see, when the r value was 0, this is the first term. When r value is 1, this is second term. When r value is 2, this is the third term. Can we guess? When r value is 3, this will be the fourth term. When r value is 4, this will be the fifth term. Similarly, when r value is n here, it will be n plus 1th term, right? Okay, so this is easy. If r equals to 3, it is fourth term, right? If r equals to 2, it is third term. If r equals to 1, this is second term. That means the order is 1 more than r value. So here r value is r. That means it will be the order of this term will be r plus 1, right? So this will be the r plus 1th term of the expansion. Okay, so here comes our fact 5, that NCR a to the power n minus r into b to the power r, this is r plus 1th term in the expansion of a plus b whole to the power n. This is very important, so you'll have to remember this carefully, that the general term NCR into a to the power n minus r into b to the power r, this is r plus 1th term of the expansion of a plus b whole to the power n. Okay, so now I said that we'll solve some maths. At first, answer this. In the expansion of a plus b whole to the power 10, what will be the coefficient of a to the power 4, b to the power 6? You'll have to determine the coefficient. At first, what you will do is you'll compare this given term with the general term. What is the general term? General term is NCR a to the power n minus r into b to the power r So the coefficient here is NCR, right? NCR. Okay. So you'll have to determine NCR, and as you can see that you are given with the value of n equals to 10. So only thing you have to do is determine the value of r. Is it that difficult? No, because in this case we see that power of b equals to 6, and in the general term power of b equals to r. So we can compare two of them and say r will be equal to 6 and a will be equal to what? Let's check. N value is 10 and r equals to 6. So a's power will be 4. So in this term, if we compare this with this term, we get a to the power 4, b to the power 6, 4, r equals to 6, right? Okay. So what will be our coefficient in CR for this? That will be 10C6. So 10C6 is the coefficient for a to the power 4 into b to the power 6. Okay, you might ask some question that if b to the power 6 and a to the power 4 swap their places, will the answer be same? Here you can see that if we compare this with this situation, here a equals to b, a and b changes their position, right? So r value will be 4 in this case. Then the coefficient is supposed to be 10C4. So do you think your answer is wrong? No, your answer is right again, because as we can remember that NCR equals to NCN minus R. So 10C6 equals to 10C10 minus 6, that is 10C4. So both of these terms are equal, right? Since these two terms can change their position, so their power, their position, if their position is switched, then the coefficient might exhibit something different, but eventually they will be proved to be the same. Okay, this was an easy problem. Okay, next problem. If you are asked that 2x plus 3y whole to the power 7, in the expansion of this term, what is the coefficient of x to the power 3, y to the power 4? Okay, now you can say that this is the same problem as the previous one. I would say this is little different than the previous one. Why? Because in the first case there was no such coefficient of a and b, but we get here 2x. So this whole 2x thing is a and this is b, a and b. Okay, so according to the general form, we'll create the general form and compare always. Okay, will be NCR a to the power n minus r into b to the power r. N value is equal to 7 here, so 7c, we don't know the value of r, that is what we are going to determine. 2x whole to the power n minus r, 7 minus r, into b value is 3y, 3 to the power r. So eventually what you will get is 7cr 2 to the power 7 minus r into x to the power 7 minus r, 3 to the power r, y to the power r, and you will get 7cr 2 to the power 7 minus r into 3 to the power r, and at last you will get x to the power 7 minus r, y to the power r. Now here comes the position where we can compare this power of x and this power of y. We need the value of y, right? So we'll see that r equals to what? R equals to 4 here, and we'll see if for this r value 4 it becomes 3. 7 minus r equals to 7 minus 4 equals to 3. So this term will become something like x to the power 3, y to the power 4, right? So this is what we are required, that we'll have to determine the coefficient of this term, right? So we'll have to determine this value, and this is very simple. 7c 4 2 to the power 7 minus 4 into 3 to the power 4. It means 7c4 2 to the power 3 into 3 to the power 4. So this is the coefficient of x cube into y to the power 4. Okay, let's move to the next question. In the expansion of 1 plus x whole to the power 44, 21st term equals to 22nd term. Okay, so x equals to what? This is our question. X equals to what? Given that in the expansion these two terms are same. At first, what we will do is determine the 21st term. 21st term. Okay, we can remember from fact 5 that r plus 1th term is NCR a to the power n minus r into b to the power r. Okay, so here r plus 1th term will be, this is r plus 1, right? This is r plus 1. 44 equals to n, right? A equals to 1 and b equals to x. So if we compare this 21st term with the general form NCR a to the power n minus r to b to the power r, here n value is 44, c r value is r plus 1 equals to 21, that means r equals to 20, a value is 1 to the power 44 minus 20, and b value is x to the power 20. So this is our 21st term. What will be the 22nd term? This is r plus 1 value now, 22, so r will be 21. So again 44c 21, 1 to the power 44 minus 21 into x to the power 21. And as we know that from the condition given here, both of these terms are equal. So we will write that 44c20, we can see that 1 to the power something is 1, 1 to the power something is 1. So we'll omit them. 44c20 into x to the power 20 equals to 44c21 into x to the power 21. Right? These two terms are equal according to the statement. So what we can do is 44c20 divided by 44c21 equals to x to the power 21, x to the power 20. Right? We were asked to determine the value of x here. So here we will get 44 factorial divided by, according to the formula, right? 24 factorial into 24 factorial. We all can remember that formula, right? 44 factorial divided by 23 factorial into 21 factorial. Formula of NCR equals to NC minus R divided by R factorial. Okay, and this will be x to the power 21, x to the power 20. If we cancel, then we'll be left with x. So eventually what we'll get is 44 factorial, 24 factorial, 20 factorial divided by 4. 44 factorial here, and upward on the upper side is x. Okay, so we can divide the both side with 44 factorial, and as we can see, this 24 factorial can be written as 23 factorial into 24. As we can remember, n plus 1 factorial equals to n factorial into n plus 1 using this identity. Okay, so this is equal to 23 factorial and 24. So here we get a 23 factorial. So it will cancel this and we'll be left with a 24 in the denominator. Again, this 21 factorial can be written as 20 factorial into 21. So we can cancel this 20 factorial and we'll be left with 21 on the upper side. So 21 divided by 24 equals to x, that is 7 by 8 equals to x. So this is the value of x, right? Okay, move to the next question. The next question is x plus 1 by x whole to the power 17. In the expansion of this, what will be the coefficient of x to the power 9? Okay, you'll have to determine the coefficient of x to the power 9. But you can ask that this is the same problem. Why are we doing this? But we have to notice carefully that in the previous problems, A and B did not have any relation between them. But here, A equals to x, B equals to 1 by x. Both of them are terms of x. So, when we will consider NCR a to the power n minus r into b to the power r, okay, then it will be a term of x, it will be also a term of x. Then eventually their power will be modified by adding or subtracting from each other, since both of them are terms of x. Can we understand that? If we don't, let's compare this with this term. 17 equals to n. We don't know the r value. We can say that NCR, a value is x, right? X to the power n minus r into 1 by x to the power r. Here n value equals to 17 c r x to the power 17 minus r, and as we know, we can write 1 by x as x inverse 1 to the power r. So we will write it like 17 cr x to the power 17 minus r into x to the power minus r. And you can see here that 17 cr, we have both of the powers of x, right? So as we know, x to the power a into x to the power b equals to x to the power a plus b. We all have known exponent, okay, and logarithm. We know that x to the power a into x to the power b equals to x to the power a plus b. That means x to the power 17 minus r minus r. Can you see that in the previous cases, a and b would remain the same, but remain different from each other. But here a and b have been merged here, right? So we will get 17 cr x to the power 17 minus 2r. Now, which term's coefficient we are opting for? Determine here x to the power 9. So 17 minus 2r will be 9, 2r will be 8, or r will be equal to 4, right? So the coefficient will be 17c4. Okay, we got that. Now, a very interesting question that we already studied before. What is it? If A is a set A1, A2, A3 up to AN, the cardinality of A is n, right? Determine the number of elements of the power set, or the cardinality of power set of A. We solved this problem before while we were studying counting problems, right? We'll do it again using binomial theorem. How can we do that? As we can remember that power set is a set of all possible subsets of a set, right? So at first we will think that in how many ways these power sets can be made. Power set is a set of subsets, right? Set of subsets. So at first there can be set of 0 element subsets, because if you take 0 elements from this, you will get phi or null, and this is a 0 element subset of set A, and this whole thing refers to this. Okay, you cannot understand this, I know. Let's see. Si is a set. What is Si? Si is the set of subsets of A having I elements. Let's compare this. S0 is the set of subsets having 0 elements in it. S1, for example, S1, what is it? This is the set of all one element subsets. As we can see, A1, only A1, this is a set. This is not an, I'm not only talking about A1, it's a set. This is a subset of A, right? This is a one element subset. This is also a one element subset. This is also one element subset. This is one element subset. These all are one element subsets of A. So S1 is a set of one element subsets, right? And similarly, S0 is the set of zero element subsets. So if we count all zero element subsets, all one element subsets, all two element subsets, all three element subsets, and how many of the element can be in their subset of A? N element subsets. So there can be n element subsets at most, because the total number of elements of A is n, right? So if we count the cardinality of all of them and add all of them, we will get the total number of subsets or total number of elements of power set of A. Okay, then how many zero element subset will be there? This is very easy, because according among all of these n elements, we have to choose zero. In how many different ways can we choose zero element? NC0. There will be total NC0 ways in which we can choose zero element. So there will be total NC0 number of zero element subsets. Then how many ways can we choose one element from this? NC1. That means there will be NC1 number of one element subsets, then NC2 number of two element subsets, NC3 number of three element subsets, up to NC n element number of n element subsets. So if we add all of them, NC0 plus NC1 plus NC2 plus NC3 up to NCn, this will be the cardinality of power set of A. Mane, this will be the number of elements of the power set of A. So are they looking something similar to what we studied previously? Yes, these all are binomial coefficients, as we can remember that NC0, NC1, NC2, NC3, all of them are binomial coefficients, right? So we'll have to determine the value of the sum of this. How will we do that? Okay, we can do this like NC0. If we multiply 1 to the power n with this, will it change the value? No. NC1, we will multiply 1 to the power n minus 1 and 1 with it. Will it change the value? No, because this will be 1. NC2 will multiply 1 to the power n minus 2 into 1 square. Will this change the value of NC2? No. NC3 1 to the power n minus 3 into 1 cube. Like this, at last we'll get NCn. We will multiply 1 to the power n minus n into 1 to the power n. Now you can ask, why have I written this way? I mean, isn't it more difficult? No, this is not. Why? As we can see from the binomial theorem, we know that a plus b whole to the power n equals to NC0 a to the power n. Can we see here NC0 1 to the power n, so a equals to 1 here. Next we get NC1 a to the power n minus 1 into b to the power 1, right? So b equals to 1. We put the value a equals to 1 and b equals to 1, and what we got here was the same as what we've written here this. So this is expressed in the form of binomial expansion, where a equals to 1, b equals to 1. So NC0 a to the power n minus 1, 0 a to the power NC1 a to the power n minus 1, b to the power 1, NC2 a to the power n minus 2, b to the power 2. If we continue this way, NCn b to the power n. This and this, both of them are equal, and in this case we can write it is equal to a plus b whole to the power n. And as we can see, what is the value of a? 1. What is the value of b? This is 1. So we get 2 to the power n. It means the sum of NC0, NC1, NC2, NC3 is 2 to the power n. And as we can see, this was the cardinality of power set of A, right? So this is how, interestingly, we can apply binomial expansion theorem to determine or to solve various interesting combinatorics problems. Thank you.